Hi guys, this is Dr. Ajanta Das. Today I shall discuss a few aspects of database management system. So if you want to discuss with me and or interact with the session after the session, then please note my email address. It's csc.dear.ajantadas@gmail.com. So today we shall cover normalizations. Within normalizations, we first discuss what are the anomalies for which we need actually normalizations to be handled. Different types of functional dependency. Then the various normal forms. Today we will try to complete first normal form, second normal form and third normal form. So why we need normalizations? Relational database design may lead sometimes inconsistency or redundancy. What is inconsistency? To understand this, we have to know what is consistency. Consistency means basically whenever we access a particular data, the data or value of that data should be same or accurate. So consistency is related to accuracy of data and rule, and redundancy means duplications of data. So the concept is that data should be saved into database, correct, and only a single copy of data need to be saved. So normalization is a technique for decomposing a relation into set of relations with using lossless decompositions, minimizing redundancy, minimizing the update anomalies. We shall discuss this minimizing redundancy and the minimizing update anomalies. Let's first understand what we mean by lossless decompositions. Decomposition means we have to divide or decompose one single relation into at least two different relations. So over here, if we consider the first relation is R and we want to decompose into R1 and R2, then obviously some attribute of R1 and some attribute of R2 should be combined together and we should get back the original relations R. So how we define this process mathematically? Pi means projections. Projection is the operations where we can only access the attributes of the relations. So MIs are the columns which are selected for R1 subrelations. NJ are the columns which are selected for the R2 relations, and combining these two, we must get back the original relations R. Hope it is clear for everyone, and where basically we can write MI and NJ belongs to the relations, all the relations, and they gives you the full relations capital R. Now what do we mean by update anomalies? Updations or update anomalies actually divided into three subtype of anomalies. This could be insertion anomalies. Insertion anomalies means which are creating problems while insertion of data occurs in the database. Deletion anomalies means from the existing data, if we want to delete any data from the database, then there should be some or there could be some problem. Modifications, if I want to change the existing value of the data, then there could be some problem. So we can consider an example of staff relations where we have the attributes staff number, staff name, position, salary, branch number, and B address is for branch address. So we can see that we have 6 tuples or 6 data in these relations with different values. So let's try to insert a new staff with branch number B001 into these relations. Let's observe that B001 branch number does not exist in this table or relation. So if we want to add that details or add that branch number with a specific staff number, we have to know all the things, otherwise all other attributes will be blank. So that is a limitations, that we cannot add any new staff to this branch. Well, next is if we want to delete a tuple. Now if we scan the relations, we can see the B007 is having only the single tuple related to this branch B007. If this Mary Howe just resigned the company or left the company, then we have to delete, and if we delete this tuple, then obviously there is no information related to this branch. That's the problem related to the deletion anomalies. Next, if branch B003 moved somewhere else, so we have to change the address. So we have to change the address in every places. It's not that only one place we update the address and it will be reflected. So that could be defined as modification anomalies. So I hope that staff branch relations we could explain thoroughly: insertion, updations and deletion anomalies. To remove all this, we have to apply normalizations, and that is the basic need why we need to learn normalizations. Now let us consider another different relations, that is the student's report, where we have student number, student name, course number, course name, marks and grade. Now the moment we add data or we are having data in a table or relations, we have to define, or it is mandatory to define, the primary key. So what is primary key? Let us understand first what is primary key. Primary key is a set of, by definition, primary key is a set of attributes which can uniquely identify as a tuple in a relation. That means for this student R001, which marks he or she got or received, John White received in this specific subject, that you can see, that is 80. The same guy had received this marks, another 80. There is a mistake in the student name, that should be the same John White. So that's the combinations, that if we can combine these two, then only we can get the specific marks. Otherwise we can't get the exact marks. So these two attributes together uniquely identifying the tuple. Now what do we mean by functional dependency? Functional dependency means basically they define the relationship between the attributes. What is the relation between this student number and student name? What is the relation with marks, course name or course number? So that we can see, if we go through this relations, we can see that if we combine this, then only we can identify that which student had received what marks in which subject. Otherwise it's not possible. So by definition, functional dependency can be defined like this: if A and B are attributes of relation R and B is functionally dependent on A, that means if each value of A is associated with exactly one value of B, each value of A is associated with exactly one value of B, that means we can have one example that set A could be the having the roll numbers of the student, set B could be the student names. So for each roll number we must have one value for B where one student exists. So if each value of A is associated with exactly one value of B, then only that is a dependency, and this is functional dependency. So over here we can also say B is functionally dependent on A. So it's never mentioned here that B has to be significantly different values, or B cannot have the same values. It is not defined. That means we can have students with same names, but all those students must have the different roll numbers. So A and B may each consist of one or more attributes. So once more I define functional dependency. With examples we are discussing, we have student roll number and student names. So in a same class we may have different students with same name, but we cannot have different student with same roll number. Why? Because to prepare the report card or to access the student's data, we need to identify that student thoroughly through that particular roll number. So over here, roll number is actually defined that particular student. So we can also say that student is totally dependent on roll number. So by definitions, if A and B are attributes of relation R and B is functionally dependent on A, then if each value of A is associated with exactly one value of B, then only we can say B is functionally dependent on A. Now, dependent on which attribute, that attribute is actually identified as primary key. So, basically we can see if we can identify the functional dependency properly, we have actually identified the primary key, because on the primary key the other attributes will be dependent. I think it is clear to everyone. Well students, can we move? Okay. So in a relations R, X and Y are attributes, Y is functionally dependent on attribute X if each value of X determines exactly 1. But the reverse is not true. Sometimes we also find that grade is measured through the marks, but that is not functional, or that is functional dependency, but different types of functional dependency. Now what are the different types of functional dependency? We need to handle 3 different types of functional dependency. The first one is full functional dependency, second one is partial, third one is transitive. Let's see what do we mean by full functional dependency. We can again explain through that previous examples that students report, where we have found that student number and course number both are together playing the role of primary key. So this is actually known as composite primary key. The other attributes are student name, course name, marks and grade. So if we want to describe the attributes, those are just given, can see or follow the slides. Directly, student number means student number, course number means course number, student name, course name, marks scored in course number by that specific student number, grade obviously obtained by the student in course number. Understood? Now, from the previous example we can see that these two are playing the role of primary key. So, marks is fully dependent on student and course number together. Student and course number together. So, marks is having full functional dependency on student number and course number. But however, we can see that course name is totally dependent on course number and student name is totally dependent on student number. So these are functional dependency, but these are not fully functionally dependent. And we can also find that grade can be measured from the marks. So grade can be measured through the marks. Now what do we define by full dependency? X and Y are attributes. X functionally determines Y. Subset of X should not functionally determine Y. So in this example we can see that student number and course number both are determining the marks of the student. So this is the example of full dependency. Let's see the partial dependency. Partial, by the word it means that while we have composite primary key, then only partial dependency can exist. So the clue is that if our primary key consists of composite attribute, then only we may have partial dependency. So, partial means one of the attribute from primary key is having the dependency but not other. So, we can see that x and y are attributes, attribute y is partially dependent on the attribute x only if it is dependent on a subset of attribute x. Subset, that means the course name is dependent on course number, which is the subset of the primary key student number and course number. Similarly, student name is dependent, partially dependent on student number, and that is basically subset of primary key. So, we have two partial dependencies. One is student name dependent on student number and course name dependent on course number, while we have the full functional dependency with course name which is dependent on student number and course number together. What do we mean by transitive dependency? As we have already found that marks is fully functionally dependent on student number and course number. Then from the marks we get grade. However, since in that original relations report, student number and course number is the primary key. So, obviously grade is also dependent on student number and course number. So, we can define by the definitions is that if y is dependent on x and z is dependent on y, then if z is dependent on x, then we say that transitive dependency exists. So, in this case we have to remove the transitive dependency. Now, let me tell you one more thing. While we have partial dependency, if we remove the partial dependency, then that normal form is in 2NF or second normal form. Similarly, if we have transitive dependency and we can remove the transitive dependency, then we have or then we reach third normal form or 3NF. So, finally, the report relations can be decomposed into this 4 sub-relations. One is student, where we have the student personal data, student number, student name and all other data if we have. Course, where we have the course related information, course number, course name. Student marks, where we have the student, particular student in specific course, which marks he or she had obtained. And the grade card, where we have the specific grades related to the range of marks. Well, so what is the process for normalizations, or let me discuss the different steps of the normalizations in brief. So, first we have to design the relations from entity relationship diagram. Then the relations should be in 1NF. 1NF means the domain of each attribute must be atomic. That we will explain again if you need the explanations. For the time being, just note down the steps. The third one is that we have to identify the primary key for each relation R. Then we have to construct that functional dependency diagram, whether it is full functional dependency or partial functional dependency or transitive dependency. Then we have to try to remove the partial dependency. If we can remove the partial dependency, I already mentioned it will be producing 2NF or second normal form. If we remove transitive dependency, then we get third normal form. Please note down the steps one by one, because this is very important while you design your database, and you have to follow the normalizations. Well, any other explanations, or can we move forward? Yes, okay. So, we are considering another new example to discuss the whole thing. So, here you can see that in this relations we have 9 attributes: client number, client name, property number, property address, rent start, rent finish, rent, owner number and owner name. Now you can see that for one client number we have the multiple data. But by the definition of relations, each cell of a relation must contain a single data or atomic data. So that is why we have to convert this relation into atomic. Let's see how we have done it. We have to remove this repeating groups and we have to do it. So we have done this like this. So the relation client rental now is having this for the same client number. We have just repeated the client number for all these multiple data. So over here we have only two clients, CR76 and CR56. Clients are John K and Alan Stewart, and they are having multiple properties, and all these are the all details. Now from the relations we have to identify the primary key. So check for which attributes we can access the specific value, or the whole tuple is dependent on that attribute. So you see, if we find or combine client number and property number, then we know that this client had taken this property from this date to this date, and that is the rent, right? For this property, the owner is this, and that is the owner name, right? You can see the same owner is having some other properties, you see, and that the same property is rented by some other clients. So obviously we have to combine these two, that which client is taking rent for which property. So that is why client number and property number both are playing the role of primary key, and this is known as composite primary key. So the functional dependency diagram or identification of all functional dependencies gives us like this: client number, property number, rent for start and finish, that is the primary key. Now you can see in this table that client name is directly dependent on client number. So obviously that is a partial dependency. You can check client name is dependent on client number, so that is the partial dependency. Also you check for this particular property, we have the same address, right? And same address and rent, same owner number and same owner name. Let's see. So property number, property address, rent, owner number, owner name. That is also partial dependency, because subset on subset of primary key, these attributes are dependent. Now we can also see that owner number is dependent on this too, and also owner name is dependent on this too. The moment we have identified that is primary key, so each and every attribute is dependent on this primary key, but owner name is directly dependent on owner number. So we can find that this is a transitive dependency, right? And these are our candidate keys. Now, how do we define? Now, since we have found that partial dependency exists, so we have to remove this, and then only we can find second normal form or 2NF. So, first we have to understand what do we mean by 2NF. So, 2NF is a relation that is in first normal form, and every non-primary key attribute is fully functionally dependent on the primary key. So, in this case, that the moment we have partial dependency, each and every attribute is not fully functionally dependent on this primary key, then we cannot say that this is in 2NF. So that is why we have to remove this partial dependency. How we can do so? Well, we have a client table where client name is directly dependent on client number. We have the rental table where we have rent start, rent finish directly dependent on the property number and that specific client number. Then we have another separate table or decomposed table, that is property owner, where we have the property details. Property address, rent, owner number, owner name, all are dependent on property number. And since that is the subset, so that is why we have decomposed in separate sub-relations, and now these three sub-relations are in 2NF or second normal form. Please take your time to check what are the sub-relations now we have. And please remember that the first property, that's lossless decomposition. Lossless decompositions means we have started with 9 attributes. Let's check whether we have those 9 attributes or not. So this 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if we combine this 3, we must get back the original relation. So that is why this is a lossless decompositions. And now for each table we can find that, what is the definition of 2NF? By definition of 2NF, we get that every non-primary key attribute is fully functionally dependent on the primary key. So in client table, CNAME is the non-primary key attribute and that is directly dependent on client number. Similarly, in rental, rent start and rent finish, these two are non-primary key, non-key attributes. Both of them are directly dependent on the primary key, composite primary key, client number, property number. In the third one, property address, rent, owner number and owner name. These 4 are non-key attributes and they are directly dependent on property number and fully functionally dependent on the property number. So we can see that these 3 sub-relations or decomposed relations are in second normal form. Now, third normal form is directly related with transitive dependency. We have already found that where A, B, C are the attributes in a relation such that B is dependent on A, C is functionally dependent on B. So then obviously C is transitively dependent on A via B. So we have to remove this transitive dependency. And how can we define third normal form? A relation that is in first and second normal form and in which no primary key attribute, no non-primary key attribute is transitively dependent on the primary key. That we have to ensure that transitive dependency does not exist in that decomposed relations. So basically we have to remove that transitive dependency. So till now we have this, right, where we had this property owner, where we have all this, but owner number and owner name is having that transitive dependencies we have to remove, and finally we have this sub-relations also. Let's see what are the other sub-relations. So now we have removed owner name from the third one and we have found the other fourth one, owner number and owner name, where owner name is directly or fully functionally dependent on owner number. So now we have this 4 sub-relations featured in third normal form. Let's check whether these are the lossless decompositions or not and verify the other properties. Please check whether partial dependency and transitive dependency is removed or not. Okay, we have verified we have till now 9 attributes, 1, 2, 3, 4, 5, 6, 7, 8 and 9, right, and that is the lossless decompositions. Okay, we have another examples with us. You can do it, consider these relations and check the primary key and then normalize the relation till its highest normal form. First go through the relation. Well, you can see the customer ID and account number. Combining this two, we can get all the details. Let's check. So we are once again going through the definitions. Check. Right, relation is said to be in second normal form if and only if it is in the first normal form, and no partial dependency exists between non-key attributes and key attributes. Right. So to make a table 2NF compliant, we have to remove all the partial dependencies. So from the second or third examples, we have this customer ID, customer name, account number, item name, unit price, class, all these are dependent on item ID, and this. So basically customer ID and item ID both are the primary key. You can also find out this functional dependency diagram. Please check. Unit price is directly related with the item name. Class, quantity purchased, how many, related to the item name. Net amount, obviously this into this, right. Item ID is related with, item name is related with item ID, and that's it. So please check. Customer name, account number dependent on customer ID. Item name, unit price, class, all are dependent on item ID. Quantity purchased and net price dependent on customer ID and item ID. Class is directly related with unit price. So which are the candidate keys and which are the non-key attributes? Please check. Sometimes instead of primary key we also say key attributes. So I have shown you that key attributes are composite, that is customer ID and item ID, and all except those two, all are non-key attributes. So how many attributes we have over here? Altogether we are having again 9 attributes. You see 2, 3, 4, 5, 6, 7, 8, 9, right? So now this is that functional dependency diagram. You can see quantity purchased, net price is directly dependent on primary key, customer ID and item ID. So that is fully functionally dependent. These two are partial dependency exist because customer name and account number are dependent on only customer ID, that is subset of this. Item name, unit price and class is dependent on subset of this. So partial dependency. And class is dependent on unit price, right? Well, so if we remove this partial dependencies, we have 2NF, that is customer table and item table, and you check that in these two subdivisions or decomposed relations we don't have that partial dependencies, and these attributes are only fully functionally dependent on item ID and in this table on customer ID. So all these are in depending on both of these attributes, right? And that is that composite primary key, so it's fully functionally dependent. Now just revise the definition of third normal form. Our relation R is said to be in 3NF if and only if it is in 2NF. So guys, if the table is in 2NF, that means it's also in 1NF. So no transitive dependency exists between non-key attributes and key attributes through another non-key attribute. Let's see this with the diagram. While B is dependent on A and C is dependent on B, so we can always say C is transitively dependent on A. So it should be the key attribute, that's the primary key, and it should be the non-key attribute, and also it should be the non-key attribute as you have already seen. Now let's see in this the last example which we are discussing, and we see that how the 3NF is achieved. So unit price is directly dependent on item ID, and class is also dependent on unit price. So we can say that class is actually related dependent on item ID. So if we remove this, we get the third normal form. So these are the decomposed relations. If you see that item ID, name and unit price, and class is directly dependent on unit price. Well, so this is the summary. You have to create separate rows or columns for every combination of multi-valued columns, and then only we will get 1NF. That should be the input for the second steps. So we have to eliminate partial dependencies and we get 2NF, and again the 2NF should be the input, and then if we operate or perform elimination of transitive dependencies, we get 3NF. I hope the process or explanation is clear. If not so, then let me know where we need to do the explanations again. Thank you very much.